Please give a warm welcome to Aaron Kofford.
It's the first time I entered a stage with theme music. It's kind of an exciting moment in my life. So my purpose in this lightning talk is to share with you one specific example of how we can go faster and how we can move projects faster and not only maintain quality, but increase quality. We've talked a lot about doing that. We've talked about how, and for those of you who have never worked with DARPA before, it's my hope that in sharing this idea of constructive virtual live testing, that you can kind of get a better idea of the scope that these projects should take. So sometimes in engineering and the sciences, we divide ourselves into theorists and experimentalists. And one cartoonist depicted a theorist as a woman examining an object in a room. And just by looking at it, she could gaze at the object from multiple angles, but she couldn't do much else because in the cartoon, she had no arms. The cartoon also depicted an experimentalist, and he had arms, but he had no eyes. And so his technique was to blindly grope around the room trying to learn what he could by trial and error. If he happened to stumble upon the object of his desire, he had minimal understanding of what he was trying to do. Clearly, we need both theory and experiment to fully grasp the understanding of the object of our studies. So constructive virtual live testing is a loose framework that pushes theoretical models from the abstract to concrete and pulls experimental data from blind observation to contextually rich understanding. Constructive models are simulated representations of what we are studying and the relevant environment in which they operate. I'm using the word constructive to invoke the idea of a simulation with a focused purpose, a place to encode our theoretical models and continually work on improving them. The virtual testing is the bridge between the simulation and the real world, and of course, in a virtual environment, you can have people and real systems interact with your theories and your simulations. Finally, live testing is where people and systems interact with the real environment, executing the real mission. And some of you who may be familiar with this framework may have noticed that I've modified the definitions just slightly to suit my purposes. We do that as program managers a lot. I also switched the order from the more common live virtual constructive to constructive virtual live. I believe the order matters. And let me illustrate, as a good program manager should, with a Gantt chart. So here, what we have is most projects begin with a hypothesis or theory. And in most cases, there's no reason to not immediately encode these into your constructive simulation. And then once you have built prototypes, you are ready to hook them into virtual testing. And once your system is well vetted and you're ready for the challenge and the expense of live testing. In my experience, this is how most projects flow in this general pattern. But it would be a mistake to consider these as sequential steps. In my experience, it is better to think of constructive virtual live testing as concurrent processes. If thoughtfully designed, constructive virtual live testing can create a virtuous cycle where each concurrent process can positively influence all the other processes. Let me illustrate with two examples. So in this first example, our goal was to better understand the attributes necessary for autonomous teamwork or autonomous team formation. We used a capture the flag autonomous quadcopters as our test bed. And in this project, we encoded both a low fidelity and a high fidelity constructive model. The high fidelity constructive model was used to ensure that our algorithms were safe, effective, and resilient to the environment. The low fidelity model was used to run machine learnings at high speeds to learn about teamwork decisions. The virtual testing started right on the heels of the constructive models, and it was used to work out the bugs and the trickier parts of the autonomy algorithms we were using and show that the real hardware was ready. At times, we would even fake some functionality so that we could parallelize development. We could overcome roadblocks by just faking some of the functionality around those roadblocks and then address those roadblocks later. I can't stress this enough. We did not wait for our algorithms to be perfect before we started virtual testing. Similarly, we did not wait for our virtual testing to be 100% successful before we started live experimentation. These processes were run concurrently. And in this way, we identified problem areas early and successfully conducted the autonomous teaming research with live experimentation. Constructive virtual live testing applies equally well to small scale, low complexity projects, as well to a large scale, high complexity projects. These photographs represent a series of complex experiments that we were using to explore the dynamics of a large maritime system of systems. The experiments used a wide variety of experimental technologies working together with well-vetted manned Navy platforms. We had elements in every physical domain: space, air, sea, undersea. And we couldn't have done it without the Constructive Virtual Live experimentation framework. Now, you may be thinking that Constructive Virtual Live experimentation is too costly for your budgets and only applies to large-scale DARPA-sized research. But I would contend that I would submit for your consideration that you can reduce your costs with a thoughtful Constructive Virtual Live design of experiments and focus more of your resources on the research that matters most. I'd ask you to consider adopting Constructive Virtual Live testing elements in your research, and hopefully it can help you get into a mindset where your research can fold right into future DARPA programs. Thank you.